Today it's Monday, November the 30th, and here we have the video for A Corporation in Japan. This is the board part number 61040-5652-10112B, serial number 112717. This is the board that we're trying to ship to Japan, and we just need some approval from the customer. The testing conditions, instead of using 400 volts AC as the previous board, this board was ordered for a 110 volts AC. So we are using 110 volts AC. Let's power the board. We're powering the board through the transformer. Go ahead, Tony. And in this particular case, you're bringing in 120. So we have a board. It is inhibited, and we have a phase loss. Let's go ahead and bring in the 240. The 240 is going through a variac, and the variac has been sized to get 110 volts AC. We're going to be monitoring the DC output just like in the previous video, and we're going to be looking at the 4 to 20 milliamp signal. And here we have the same three signals: test point 5, the A phase reference, TP channel 1, which is TP3, that's the delay angle with respect to the A signal for the plus A SER, and we have the DC output. We're also looking at the frequency of the board, working frequency of the main, 60 Hertz. We're going to be able to take a look at the delay angle here between phases 3 and 1, between channels 3 and 1, and we'll also have here the average DC output, which is what we have out here. So let's go ahead and enable. We're enabled now, and we're going to move to 4 milliamps. Let's get in at 4 milliamps. We have 124, 125 degrees, and our output is negative because of the area under the zero curve. It's more than the actual base. Alright, Tony, go ahead and slowly start increasing from 4 to 20 milliamps. And what we see here is that the delay angle gets reduced. We have the 6 and a 60 Hertz. We have the 1, 2, 3, 4, 5, and 6 SER outputs. We have the 6 SERs conducting, and what we have here is 60 Hertz. The delay angle, it's from 9.8 to 10 degrees, and the maximum DC output is 141. At this point, we have our 141.9, 142 volts DC. The AC input is 110, and we have 20 milliamps. Again, the biggest concern here was the delay angle, which is this right here, and we can see it from here to here, and that is measured to be, it fluctuates between 9.5 and 10.3 degrees. So Tony, if you can slowly, by the way, and the corresponding voltages for 20 milliamps is 5 volts. Can you go a little high, Tony? 21, that's probably good. We'll see here now that the delay angle has been further reduced to about 8.6 to 9 degrees. The average is 9 degrees. So could you slowly come down while we take a look at the screen? Okay. Want to stop there? Here we have 60 Hertz. We have a 60, 59 degrees. The corresponding output, it's 84 volts. Here we have on the average voltage, DC output, it's 76 volts. We still got the 110, and we have a 13.27 milliamps. And we just keep on going until we get to 4 milliamps. That's good. Where we are back again at 4. We got the 110, 111. We got a negative output, and we got the same AC output. So again, this is the data that has been requested, and hopefully here we're shown an effective delay angle range of 125 degrees to about 9 degrees. This is the end of this video.